Good morning, everyone. Once again, welcome back to Shadow Social College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer, Jagadish. Okay, you guys already know we started your BSc 5.2 Laplace transformation classes, and in last class we discussed about your some properties of Laplace transformation. In that, we studied change of scale, first shifting property, multiplication property, and division property. Okay, so today I am going to take your next property, that is fifth property, your derivative property. Okay, guys, we just one recap your in last class what we studied. Okay, okay. I hope you see this screen. In last class we studied the first property, that is change of property. Okay, your first change of scale property. Change of scale property, that is your first property. That your statement is if Laplace transformation of statement is if Laplace transformation of log of t is equal to f of s, then okay, then Laplace transformation of f of a t is equals to 1 by a into f of s by a. Okay, this is your first property, that is change of scale, and the second one is first shifting property. First shifting property, that said our statement is if Laplace transformation of t is equals to capital F of s, then Laplace transformation of e to the power at into f of t is equals to your f of s minus a, or we'll write it as Laplace transformation of e to the power at f of t is equals to Laplace transformation of f of t, where s tends to s minus a. Okay, s tends to s minus. Okay, and our third property, that is multiplication property. This multiplication into t to the power n, and your statement is if Laplace transformation of t is equals to f of s, then Laplace transformation of t to the power n into f of t is equals to minus 1 to the power n d to the power n divided by ds to the power n into your remaining Laplace transformation of f of t. Okay, so this is the statement of your third property, that is multiplication property, and also we studied your fourth property, that is division property. Your next property, that is division property. The second is Laplace transformation of t is equals to of s, then Laplace transformation of f of t by t is equals to integration over s to infinity and your remaining Laplace transformation of f of t into t. Okay, so this is your fourth property, that is division. So we studied first change of scale, second one is shifting property, and third one is multiplication, and fourth one is division. Okay, so today I am going to explain your fifth property, it is derivative property. And your next sixth property, that is integrating property. Okay, so first we'll study your today's, that is derivative property. Okay, so this is your Laplace transformation of derivative of property number 5.1. Okay, 5.1 of called phi of a. Okay, so let me start. The statement is if Laplace transformation of f of t is equals to f of s, this is common for all property. Okay, then we have to do that Laplace transformation of f dash of t. Okay, Laplace transformation of f dash of t means derivative of f of t is equals to s into f of s minus f of 0. Okay, so we have to do this function using this one. Okay, let me prove what we have in our property 5.1, it is Laplace transformation of f dash of t, okay, is equals to integration over 0 to infinity e to the power minus st f dash of t into dt. Okay, this is our according to our definition of Laplace transformation. It is we have integration, sorry, it is we have Laplace transformation of f of t is equals to integration over 0 to infinity e to the power minus st into f of t into dt. Okay, so this is our definition we have. So in f of t function we have f dash of t. Okay, so that's why we will write instead of f of t, we will write f dash of t. Okay, simple one is Laplace transformation of f dash of t is equal to integration over 0 to infinity e to the power minus st f dash of t into dt. Okay, so this is our equation given by definition. Okay, so when we write once we write this function separately, is integration over 0 to infinity e to the power minus st f of t into dt. Okay, so your integration by part formula is there. Okay, integration by parts formula is there. So using that formula, we will solve this function. The formula is integration of u dx is equals to u function as is integration of v into dx minus integration of u dash, that is derivative of u, sorry, a derivative of u and again integrating of v dx. Okay, so this is your integration by part formula is there. Okay, so using this formula we solve this function. It is u value is e to the power minus st and the v value is f dash of t. Okay, okay. Sorry for disturbance. So this is your function using this function, uh, so integration by parts formula is there. So using this formula, we solve this function, that is integration of u v into dx, that is u as it is integration of v dx minus integration of derivative of u and remaining integrating of v dx. Okay. So using this formula, we solve this function. Okay, so here we have u is equals to e to the power minus st, and we have f dash of t. Okay, so let's see the formula here. It is e to the power minus st as it is u function, and derivative of integrating of f of t with respect to dt. Okay, this is first function. Okay, minus second function is integration of, okay, integration of u dash. U dash means derivative of e to the power minus s with respect to t. So in that we get minus s into e to the power minus s. Okay, and remaining your this function, that is integration of f dash of t into dt. Okay, and the whole dt1 function is there. Okay, so this integration is dt. Okay, this function only I write here is u function integration of which one here. Here is u function integration of v dt minus integration of u dash into integration of v into dx. Okay, so here we have v value is f dash of t into dt, u value is e to the power minus s. Okay, so next step, when we solve this function, here we get one lower limit and upper limit, that is integration over 0 to infinity here. Okay, that is e to the power minus st integration of dash of t into dt with respect to our limit 0 to infinity, minus our remaining integration over 0 to infinity, derivative of e to the power minus st is minus s into e to the power minus s. Okay, I into our remaining integration over f dash of t into dt and whole function with respect to dt. Okay, see here we have here that is derivative and integrating derivative and integrating at the same time. That's why we will take cancel here. This integration and derivative will get cancelled. We will get e to the power minus st into only f of t. Okay, here we get only f of t with respect to 0 to infinity, our limits, minus integration over 0 to infinity. This function we will write as it is minus s into e to the power minus s. Okay, so here also we will get the integration function and derivative function will get cancelled, and here we will get f of t into this whole dt function as. Okay, and your next step is it is integration of e to the power minus st into f of t. Limits is 0 to infinity, and this function I will take outside, that is minus into minus plus s, and remaining integration over 0 to infinity e to the power minus st f of t dt. Okay, so in this next step, when we apply the lower limit, upper limit minus lower limit, we'll get here it is e to the power minus st f of t. Okay, our limit is infinity 0 to infinity. So when we apply the upper limit, that is e to the power infinity f of infinity minus e to the power 0 f of 0. Okay, so this function will get cancelled here. That means 0 minus e to the power 0 means 1 into f of 0. Okay, so this function we will get only minus f of 0 here. Okay, and right here only it is when we apply the upper limit to here, e to the power minus infinity f of infinity minus e to the power 0 f of 0 plus your remaining function as it is s into integration over 0 to infinity e to the power minus st f of t dt. Okay, and here your next function it will become 0 minus e to the power 1 means 1 and remaining function as it is minus of f of 0 in this function plus s as it is, and this is our definition of Laplace transformation. It is f of s. Okay, so here we will get our answer is yes. First we will write a positive term, that is s into f of s minus f of c. Okay, and our final resultant answer is Laplace transformation of f dash of t is equals to s into Laplace transformation of this function I will write as Laplace transformation of f of t minus f of 0. Okay. Okay, I will go for your next property, that is 5.2. Okay, in 5.1 we studied single derivative. In 5.2 we studied double derivative. Okay, this statement is same. If Laplace transformation of f of t is equals to f of s, then Laplace transformation of double derivative. Okay, that means f double dash of t is equals to, we have to do this one, that is s square of Laplace transformation of f of t minus s into f of 0 minus f dash of 0. Okay, we have to prove this function. Okay, proof. First, we'll take the given equation, that is a Laplace transformation of f double dash of t, that is double derivative. Laplace transformation of f double dash of t. This function we will write as first Laplace transformation of first derivative into whole derivative. Okay, so so this function we have, okay, that means we just solved our 5.1 property. It is Laplace transformation of f dash of t is equals to s into Laplace transformation of f of t into, sorry, f of t minus f of 0. Okay, we just solved this property 5.1. So using this property we solve this function. It is Laplace transformation of f of t. Instead of writing this function, we will write this one. It is s into Laplace transformation of f of t minus f of 0 and whole derivative is there. Okay, when we separated this function, s is constant term, we will take outside, and remaining Laplace transformation of f dash of t minus this function f dash of 0. Okay, okay. Okay, now again we will get here the same function and same property, that is Laplace transformation of f dash of t is equals to s into Laplace transformation of f of t minus f of c. Okay, so again we will get one more function here. So using this function, okay, using my 5.1 function, we will solve it. That is, instead of writing this function, we will write this one. This s is constant outside, and this remaining function is Laplace transformation of f dash of t is equals to s into Laplace transformation of f of t minus f of 0. And this function as it is, that is f dash of 0 as it is outside. Okay. Now, when we multiply to this function, we will get s into s square into Laplace transformation of f of t as it is. This minus into plus minus s into s into f of 0. Okay, and remaining this f dash of 0 as. Okay, so our final result answer is Laplace transformation of double derivative of t is t square, sorry, s square Laplace transformation of f of t, yes, f of 0 f dash of. here we will get x to the power 2, x to the power 1, x to the power 0. And when we will get the third derivative, it's triple dash of t. That time we will get s cube, s square, s1. Okay? Okay, we will explain this one again. Okay, see here. This is your 5.1 derivative of Laplace transformation of derivative property. Okay, this Laplace transformation of f dash of t is equals to s into Laplace transformation of f of t minus f of 0. This is your first derivative, and this is Laplace transformation of double derivative of t. Okay, this Laplace transformation of f double dash of t is equals to s square into Laplace transformation of f of t minus s into f of 0 minus f dash of 0. Okay, this is your second derivative. And similarly, we have Laplace transformation of f triple dash of t. It is s cube of Laplace transformation of f of t minus s square of f of 0 minus s into f dash of 0 minus s into s to the power 0 here, s to the power 0 into f double dash of 0. Okay, so similarly this is third derivative. So similarly our nth derivative is, that is Laplace transformation of f to the power n t is equals to s to the power n. Okay, here 3, here 3, here 2, here 3. That's why s to the power n into Laplace transformation of f of t as it is minus Laplace transformation of s into n minus 1. That is, if you are 3, will get 2, 1, 0. So here n minus 1, n minus 2 up to n to the power 0. Okay. So here Laplace transformation of f of t, f of 0, f dash of 0, f double dash of 0, f triple dash of 0 up to f to the power n minus 1, 0. Okay. I hope this one is clear for you all. Okay, if you have any doubt and any query regarding to this class or in something previous class, don't hesitate. Take a screenshot or write the notes or simplify. Take a separate note for that question and send me through the WhatsApp. I will clear that problem. Okay. Thank you all.